Imagine a person climbing a steep hill at 3 kilometers per hour, then descending that same path at 6 kilometers per hour. If you had to calculate the average speed for the entire round trip, the most common answer is 4.5. 3 plus 6 is 9 divided by 2. But that number is mathematically inaccurate. It is the result of the brain's preference for simple arithmetic over the physical reality of the trip. This specific problem is part of a 15-question series designed to highlight these types of mental blind spots. Calculation speed matters less than recognizing when a problem is designed to exploit a specific intuitive bias. Working through these challenges suggests that logic is less about innate ability and more about building a defense against cognitive illusions. Pattern recognition is the first defensive layer. Consider this set: 41, 47, 57, and 53. One does not belong. The outlier is 57. While the others are prime numbers, 57 is divisible by 19 and 3. Identifying shared properties isolates the exception. Patterns become more difficult to track when the sequence scales at a non-linear rate. In this sequence, the gap between numbers grows constantly. Instead of adding a fixed value, each step multiplies by an increasing integer, first by 2, then 3, then 4. Strong pattern recognition involves looking past the surface numbers to map the structural rules connecting them. Some problems require moving outside of standard arithmetic entirely. Take the classic scenario of a farmer moving a wolf, a goat, and a bundle of grass across a river. The boat can only carry one item at a time. If the wolf is left with the goat, or the goat with the grass, the trip fails. The solution forces you to take the goat across, then later bring the goat back to the starting side to swap it for another item. You have to move backward to eventually move forward. A similar lateral hurdle appears in the riddle of 7 brothers who each have one sister. A common reaction is to assign a unique sister to each brother, leading to an estimate of 14 children. However, since they are all part of the same family, they all share one sister. The total is 8. This demonstrates how lateral logic resists the urge to multiply entities, focusing instead on the relationships between them. Returning to our hill climbing problem, we can now see why 4.5 was the wrong result. This requires the harmonic mean. A simple average applies only when time is equal. Because the climber moves slower going up, they spend twice as long on the ascent. Accounting for that extra time brings the true average to exactly 4 kilometers per hour. Another trap involves calculating total handshakes if 10 people in a room all shake hands once. Initial reactions often lead to multiplying 10 by 10, but that double counts every interaction. The first person shakes 9 hands. The second person only has 8 new people left to meet. Following this descending addition, 9 plus 8 plus 7, the total comes to 45. Navigating these problems requires moving past initial reactions to apply a rigid, structural framework. When these types of problems are aggregated into a full 15-question set, the results provide a snapshot of your current logical habits. Most people fall into the average tiers, which represent a mind that is still learning to identify the cognitive illusions we've discussed. High scores correlate with a cognitive framework that can consistently identify and bypass these specific traps. Ultimately, these scores reflect a current set of logic habits. They can and will change as those habits change. Engaging with strategy games and deliberately slowing down your response time can help build the pathways necessary to catch these errors before they happen. Intelligence, in this context, looks like a set of habits, learning to map the structure of a problem before the brain reaches for the easiest answer.